So thank you. Hello, everyone. My name is Talby. I work at TGO. We're a software company based out of Bellevue, Washington. And we're a fully integrated big data stack, meaning that we build complete solutions. So solutions include the big data infrastructure, the data science, and the application layer. And what it means is that it works particularly well for problems. We actually need models that learn in production, update in production, right? Because we take responsibility for the actual business outcomes of the production system. And this is one of the problems that shows this very well. So the problem we're going to talk about today is the challenge of finding rogue traders in a financial services scenario. This is an example of a project we did with a top 5 US bank. And the challenge is to find a case of internal compliance issues, which is a big problem. It's a big problem because right now the way we're fighting it is really with regulation, over-regulation, which makes it very hard to tell between real bad actors and people who just need access to banking that we are not giving to them. It's a big problem for the banks. They are being hit with internal issues, which they are having trouble finding about in advance. It's a big problem financially. So the top UK banks lost about a fourth of their revenue, not profit, revenue, in the past 5 years to fines. And obviously, it's in terms of just the public image, it's an issue as well. So there's a real interest from the banks themselves to solve this problem, both to make sure they're actually doing it right, as well as the financial incentives that goes with it. So when you're trying to look into this kind of problem, what we did is we had access, which you can do if you're a trader. You give away a lot of access in terms of your communication, your trades, so people can see what you're doing in terms of you're trying to do money laundering, bribery, political contributions, breaking Chinese walls. There are many ways where you need to open up your communication to allow for that. So we can get a stream of communications, email, IMs, and such. We can get transactions. And then the goal is to find out if someone is doing something funny. And there are 3 interesting challenges when you do that. The first problem is that this is a number of true negatives that we have. Meaning that when we get the stream of messages, of transactions, about 1 in a million is what human experts would consider not even a true positive, but even a suspect. Right? Something that is relevant to look at. Okay? That's 1 in a million. This means that just about any supervised machine learning algorithm you would try would tell you immediately, no matter how you try to game it, that all messages are good, and you're getting those 5 nines of precision and accuracy, and there's just no way to go and beat that number. So really, you need to take a different approach. You need to start ranking some of your suspects and looking into them. That's problem number 1. So it really is a needle in a haystack problem. Problem number 2 is even if somehow you were able to get beyond this and get some reasonable training data of real bad examples, the next problem is that you have no training data because there are only several hundred or several thousands bad examples that happen in 1 year. And it takes a very long time to investigate and actually validate one training example. Right? So if you've been following cases of financial fraud in the news, it takes usually large teams of forensic accountants and lawyers several months to even agree if there was a crime. And if there was a crime, really what was the actual regulation that was violated in a long stream of concocted scheme that someone brought up. Meaning that you cannot go in and come and say, okay, just give me the definition of what's fraud, or give me enough examples and I'll train to that. It needs to be much more of an online version where it's a semi-supervised problem. You get some hints, and you get more examples over time, and you need to train the system while you're in production. The third problem that you have was, even if you were able to somehow get over the previous 2 problems, this is what's called an adversarial learning problem. Okay, an adversarial learning problem is a machine learning problem where once you give me training data, I train on it, but once I start making guesses, you actually change your behavior so that my results decrease. Okay, and specifically in financial services, if we were all traders, every time someone would get caught, right, we would all go into a room like this, and going to compliance training, and people come and says, look, here's what this person did. They did 1, 2, 3, 4. Here's how we caught them. And if you're a bad actor and you're sitting there in the audience, you take notes, and obviously you're not going to try the same thing. So what you see is that almost every new type of scheme that's been uncovered is new. Okay, which always makes it hard both for human and machines to try to understand what's going on. So we need a different kind of approach here. So just to summarize, we do have a needle in a haystack problem, and the approach we'll take is what we call hybrid analytics, which really means that you can't, no one trick works, and we see how we take different signals from different kinds of approaches to make that work. There is no training data, okay, so we have to take a semi-supervised learning approach, okay, meaning that we start with the low baseline, we go into production, we start getting hints, and we learn while we are in production. Okay, and because this is really a textbook example of an adversarial learning problem, similarly, you have to have an online feedback system, right? So another important thing with those kinds of problems, your offline metrics, your classics or your precision recall on your offline training that almost don't matter, right? Because you know that it's not going to be what you face in production. Really what matters is while you're in production, what's your rate of success and can you keep it over time? So when we talk about hybrid analytics, really the question is, okay, we're trying to catch this rogue trader who's planning something. What are we really looking at? Okay, and what we need to look at are the different kind of signals that we are trying to catch. All right, so when someone starts thinking about the fact that they've been in a bug for 5 years, they hate everything, and it's time to plan the X million dollars and get away, things change, right? So the first thing is they do begin to think and talk differently, right? They become disgruntled. They think that somebody owes them something, right? They think that people are against them. They think that the world is extremely unfair against them, right? And you can see it in how they talk, in who they talk to, right? In how they behave. When they start doing something, you definitely see that they change who they work with. So sometimes they start working with people that are completely outside their departments, right? To try to coordinate different kinds of schemes. Sometimes it's the reverse. They actually centralize their business with only 1 or 2 people. But you see those differences, you see those changes. Obviously, timing of events is important. What you want is you want to be able to have some kind of routine analysis. And then you could look for simple things like, maybe I'm starting to come later in the morning, right? So you can see that my emails and transactions are starting later in the day. Or it may be the case that I'm starting 2 transactions. Usually, it's not usually the Sunday 4 a.m. thing. Usually what happens is the end of quarter or end of month, when there's a large stream of payroll or tax or other transactions, and you can so hide within the crowd better. Obviously, people start actually breaking rules, but rules in the financial services space are not easy to define. First of all, you do have tens of thousands of pages of just regulation, which are very hard to encode. But on top of it, I don't know if you've ever been involved in a tax audit or any sort of financial audit. There's the regulation, and then there's the standard that the auditors expect, right? Which is much more of a fuzzy thing that you need to be aware of. And obviously, what you're looking for is a combination of all these things. And one thing to note, if you're building those systems, is you're not looking for specific signals or specific, midnight email or an email to a person that I don't usually work with. You're looking for a change in behavior. Okay, and what you're trying to see is you're trying to catch people in decline before they actually do something that's regrettable. Analytically, each of those types of algorithms means that you need to look at a different set of algorithms, right? So you definitely need strong natural language processing. You need to be able to understand emails, text in depth, and show you some examples of what we had to deal with. You need to understand graph analysis and link analysis. One thing I can tell you as an example, we've done similar projects in healthcare. In healthcare, I can tell you if you have one doctor who you identified as a bad actor, then the doctors who refer patients to that specific person are 7 times more likely to also be bad actors. Okay, so here's a free feature that was one of the strongest features we have found. You need to be able to understand time series analysis very well, to look at routines, look at daily cycles, weekly cycles, and deviations from them. Obviously, you need to be able to understand rules. And most importantly, when you're building your models, what you must not do is just take those types of features and combine them into one classifier. That fails completely in general in machine learning. When you take those completely different types of features and combine them into one classifier, what's going to happen is that some features are going to completely overtake and dominate over others, just because it depends on the classifier. So some classifiers use natural language processing. You have a feature pair, a bigram, you're just going to have too many features. Other classifiers are going to have maybe the time series features will dominate. So what you need to do is build separate models and separate classifiers for the different types of signals, and then build ensemble models on top of those. And that's how you go and improve and actually have those features impact what you do. Any questions so far? OK, so what we did here is want to have something that you can play with. So we built an example that's based completely on open source tools. So it's Python based. The Jupyter notebooks are available on TGO's GitHub, and they've been there for a while. Many people have tried and hacked away with them, and actually sent us some very interesting things. And the goal there is just to show a reference architecture about how you go and build those systems. So it's all open source, and there's a AWS Marketplace Jumpstart if you just want a one-click thing. In terms of how the notebooks work, there are two levels of data processing in such an architecture. The first one is what you do with just a stream of emails and transaction that comes in. And what you need to do is, in this case, we use Kafka, and then we use Spark streaming to go and pull and process the data as it comes. Usually, we're dealing here with several terabytes per day, so this actually is a big data example. Most data science examples are actually not big data example. This one absolutely is. And what you do is you just do the basic per transaction features, right? So if it's an email, and I can move over to notebooks here and show some of the examples in the demo notebook. But if it's an email, you can look here. Let's see, this is on the transactions. This is on the email. So what we do is we tokenize the content, we tokenize the subject. We have two types of sentiment analysis here. So passive-aggressive and dominant-submissive. We do some topic modeling, right? Because you want to understand the topics, and running topic modeling regularly is very important because there's a lot of jargon in the text here. There's features you want to run on the transactions as well. So here we process them. We look, whether transactions are considered large or not, whether considered unusual time of day or time of peak transactions. And basically what you do here, let's go back to here. You're just doing the basic per transaction processing. Okay, and then you can, you aggregate them into users. There are some examples here. Some of the things we look at are things like, when do you send emails? Who do you send them to? Which domains you send them to? How your sentiment changes. On the language front, the one thing I would say is you really need a strong natural language pipeline here, and you need one that's custom to this domain. Okay, so if you're dealing with emails, you need to look at things like replies, forwards. You need to look into attachments. We have things like, especially when people are trying to hide something, they will use a foreign language, right? So Latin alphabet, by speaking a foreign language, they would attach an image and in handwriting write a note. If they use IM or text messages, obviously the grammar is not a complete. Nobody uses full grammar when they do that. But on top of it, there's a lot of jargon, a lot of code words that are being used that you need to learn. Other than that, you need to be able to understand negation. You need to be able to understand compound sentences. You need to be able to understand who we are talking about, right? So it's very important, which person I'm talking about, which project I'm talking about, what action am I asking someone to do. Okay, so if I'm texting my wife because someone told me, which they shouldn't have, that an M&A is going on, we need to be able to track that. And there's, so that's some of those examples you'll see in the code here, right? And some of what whatever is open source we added. On the graph analysis piece, I'm not going to talk a lot about, but one thing to note is also when you're working on those kinds of needle in haystack problem, you need basically different graph analysis problems than probably what the usual ones we all know and love. So this just an example. If you use, let's say you have this kind of visualization. This is just dimensionality reduction for 2 dimensions. and I'm trying to find those two green clusters, which are two interesting clustered events. If you use k-means on this, right, it's just going to differentiate between the left side and the right side, right? So k-means tell you that here's the center of one cluster, here's the center of another cluster, right? Because there's so much background noise, right? If you look at this k-means, look, most of it, yeah, they're just points all over the place. Okay, and this is how most of these algorithms work. There are other algorithms, okay, that would do better. Okay, for example, one that we've used here is the Bregman bubble clustering, that will basically tell you, here's one cluster, here's a second cluster, everything else is noise. Okay, and one of the things we've had to do is actually go back to research and implementation of other algorithms, which is something you definitely want to do. The next thing that you need here is you need a second layer of processing that is not at the transaction layer, but is at the user layer, right? Because there's never one email that's going to read out the whole scheme. I mean, nobody is that stupid. It's going to be a long stream of things that tie together between many people and many events. So what we do here, there's a separate Spark process that runs either every few seconds or every few minutes, depending on how much data you have, that basically retrains in production and builds a new per-user model. Okay, and what we do here, we build features that are per user, right? So if at the message level, my NLP features are what's the sentiment of a message. At the user level, it's what's the average sentiment of this user, right? Or what is the change in the sentiment of this user from the past day or the past week. Okay, so that's a different level of aggregation. Similar for graph. Now I'm looking at what are the communication partners of this user in terms of are they changing the number of people they're communicating with, their graph size, their click size, and so on. Just as a tip, it's more important to look at changes than to look at the absolute numbers. So what I do here is I build those user-level features per user. I apply the feedback, right? So I do have human agents who are looking at my leads and say, yes, this is relevant, this is not relevant, and I rebuild those classifiers. Okay, and with enough data, you can really do this every few seconds. And then with the feedback from the agents, right, and with retraining both things like your topic models, but also just rebuilding the graphs, you actually have a system that learns here while in production. And what you have here, you have the notebooks that show this training process where we apply the feedback. We use here what we use. We actually package the Python scripts within Spark SQL UDFs, so we can actually do both the feature engineering and the training in a distributed fashion. And you have the notebooks that go and do that. And let's see. So just to summarize what we have here. You have the notebooks. You have separate notebooks, one for the overall, just go one more time, one for the overall demo, and then there's separate notebooks to look at specifically the graph features, to look at the time series features. So we generate ARMA models. We look at different types of outliers. Right? Because actually there are features that show you how you build people's routines. And then there are some email features here, mostly focused on topic modeling and sentiment analysis. And then the main demo notebook shows you how you go and combine these. What you need to do if you're interested is just go on down and play with them. Obviously, some of the more advanced features we have are not there, but what you have here is all open. And I do think, having done this for several years, that this is the correct reference architecture for thinking through these types of problems, where you need to have one stream where you look at each message or transaction, but you do need to have that second layer that is batch and scheduled. We go and retrain a model that really is per user or in general per actor that you're looking to go after. What this enables you to do is, first of all, actually get some traction, and we have a system that has human investigators who go and look at the rank results and work them, and we've been able to get some very sort of like best ever results from doing that. The other very cool thing that happens here is you have a system that actually learns. Okay, and what happens is that you have a system that in production changes its models due to changing behavior of the actors, due to feedback from the investigators, which is very nice to see, because what happens after a few weeks or a few months, you actually go back to the system just to learn what's going on. Right? It's usually the reverse, because usually today we still rely on data scientists to go and update models and do feature engineering. Here we actually got to a point where we do the reverse to understand what's happening. Thank you. Yes.
So on the topic of the rareness of the event you're searching for,
Yep.
I actually work on phishing detection. It's a similar problem. It's about 1 in 10,000, so not
Yep.
quite 1 in a million. But we found that weighting the examples works very well. Does it not work when you get to the 1 in a million?
Yes, so one easy, very easy cheat is to come and say, yes, just take the few examples you have and either weigh them higher or duplicate them, right, with some variance in your training data. We did this at the beginning just to get some results. The problem is that we had here is that the schemes change too quickly, right? So yeah, with phishing, the good thing is, yeah, once you found the scheme, probably many people will try it, right? And with phishing, or a lot of times, with tax evasion, those kind of things, you have very few sophisticated actors, right? But then the majority of people just try to do the same things, right? Here, we just don't have the luxury of the long tail. So yeah, but that definitely works, yes. Yes?
Can you talk a little more about how you test the classifiers?
That's an excellent question. So the question was about how we test the classifiers. And the real challenge here, as I was saying, is that your usual offline metric they're basically meaningless, right? Because to the point, if I just make very small changes to my training data, I could, double or triple, my recall. That's one thing. The other problem is that, really once you put this in production, right, then by definition, people are going to react within a few days or a few weeks, right? So really what you're looking for is the team of human investigators working on this, looking at their feedback. Okay, so at the beginning, we're looking to see how many leads that we're actually following up on, right? Because when you do this, especially when you start with the NLP things, the first thing that comes up is the monthly compliance email, right? That email goes out to everyone and comes say, here's who we caught last month, and here's what should be careful, right? Because it hits all the keywords, right? And then 1 or 2 people come say, this is not relevant, right? And then the system retrains and it goes away, right? So, but one good thing is you just have the feedback from the people. Either you ask them or just you see what they're working on to see are they actually getting good leads, right? Are they actually working the top ones? And the other thing, you can really only see what's happening in production in terms of, over a few months are really, catching more or less, which is also how to measure, because it's not, very often it's like, if I start stealing money, it can be finished with, a talk with my manager or talk with HR, right? And if it's, there's a long time before SEC comes in, right? And very often even the bank is unwilling to tell you yes, there was actually something there, because they'd rather keep it lower. But a lot of it is your online feedback, right? What we have learned is the offline metrics are almost useless.
And have you been able to generate any artificial test data sets based on historical ones?
Yeah, so I think that was similar to example here. When you want to bootstrap, you definitely want to do that, yes. Yeah.
Unfortunately, that's all the time we have for questions.
Okay.
Thank you very much.
Thank you.